Okay, so I'm going to talk about a toy web framework written in Swift. So it's a toy, it's not production quality. So actually I'm really nervous because the next speakers, they have already set up what they want to demo. And if you see what I see, I took a photo. It's like how many of you can talk with, I don't know, Samsung Note 7 over in front of you? This is very high level. Okay. Anyway, my talk should be, I think it's the only one where I don't talk about iOS development. So yesterday, many speakers talk about improving your build compilation time. I thought I should do my bit. So this is one way to improve your compilation time. Next week, we can all get new laptops. Yeah. Okay. So why build a toy web framework? Actually, I like to walk. Why build a toy web framework? For one thing, I've never built one. It's a well understood domain. It's relatively simple. The basic premise is you have a HTTP request, your application does something, and then you generate usually a piece of text, right? Normally HTML. So I use this basically as a vehicle to explore a few Swift language features, what they can do and what they can't do. There are already more than a handful Swift production quality web frameworks. So this one is not one of them. This is incomplete. It doesn't work. It's not optimized. But in this talk, I'll mention also other language features and frameworks which I think are relevant because there's a lot that we can learn from each other. So what is a web application framework? These are more or less the basic components. There are also optional ones like real-time messaging. I call my framework Blamework. So if anything goes wrong, it's the Blameworks problem. Okay. I took ideas from other languages and frameworks over the years. Most of us, I have worked with several languages and frameworks. I am very interested in seeing how some of the features can be implemented using Swift. Some of those will not be realistic. They cannot be used in production. Model View Controller, MVC. I guess by today, all of us should be very familiar with this design pattern. It's the same MVC used in Cocoa and Cocoa Touch. In the web space, ever since Ruby on Rails has been released about 10 years ago, almost every modern web framework released since has been using MVC. But in the web application world, there is usually a more explicit router component. The router basically just accepts HTTP requests and then forwards control over to your piece of code which is relevant. Right? In the web space, this is usually the controller. Before we get started, normally I write code using MacVim, but for this project, I decided to use Xcode instead of Vim and SwiftC directly, so I can use Playgrounds. I should probably use KZ Playgrounds. Yep. Yes, I'll fix that. Maybe in the next iteration. Right, so the one thing is, if you create an Xcode project and then you drop Playground files into it, one advantage is you can access libraries from Cocoa Pods and Carthage libraries. Your Playground file itself can also include additional Swift files in the sources directory. Those are compiled, so when you make changes to your Playground, the updates run faster, right? So yeah, KZ Playgrounds. I cheat. This is supposed to be server-side Swift, but I'm using this Cocoa pod called GCE Web Server. It's a very nice web server. So what happens is that I have outsourced the most difficult part of web application framework. I don't have to build a web server, standard-based. This is how I wire up GCD Web Server. I basically forward all the requests over to Blamework, wrap it with a request struct, So this is what happens. The primary 4 components are being handled by GCD Web Server and Blamework. This is an example in Ruby for the Sinatra framework. What you see here is it specifying a HTTP verb, the URL, and then the text, the HTML to be returned. Right? So this is how many web frameworks handle routing. Right? If you have a more elaborate framework, you just need to expand on this line, build up MVC structure, you can build out additional components, and it will all work. So that was in Ruby, but in Swift, there's a framework called Vapor. You can see that it follows roughly the same routing pattern. There's another one called Perfect, slightly more elaborate, but still the same thing. But in Blamework, since it's a toy, I want to try something different. So instead of the pattern that was used by Ruby Sinatra, what I do is we can create a map, a dictionary. It maps between the URL and an object. And the object is basically a component. So the component is responsible for rendering a part of the HTML. Right? So within Blamework itself, the router just extracts the component that is relevant for this route and asks it to render the request, the response for the request. So what do I mean by component, right? So using components, Blamework can let you build a web application in this manner. So you can have something like a header, footer, navigation bar, tools, and so forth. These components can be more reusable. So many existing server-side frameworks are template-based. Template as in think more like raw PHP with string interpolation. Right? If you think about it, this is actually really fragile and not reusable. And you have a mismatch of paradigms because on one hand, you might be coding with object-oriented code. And then on the other side, you are editing very extremely long strings where you put in stuff in variables for string interpolation. This is, to me, this is a bit crazy. This is actually very similar to how some people, when doing iOS app, uses storyboard, and some people don't. You can see there's some parallels there. Anyway, different tools, different best practices. In this talk, I'm not going to be talking about nested component hierarchy because there's no time. But I'm going to focus on a single simple component, a to-do list. Right? There's just one component here. This is Swift code. This is inspired by a framework which I use called Seaside. It was written in Smalltalk. This provides, basically provides a DSL to build HTML. I've included a Wikipedia reference. If you don't know what it's a DSL, basically a DSL is a mini language which you can build within your framework or application or library, which is specific for a certain purpose. For my purpose, I want to be able to build HTML pages. Okay, so this is an example of what I have in Swift on the left-hand side, and on the right-hand side is how the same DSL would look like if it was implemented in Ruby. I just want to point out a few, actually one difference maybe. If you look at if you compare the first line, the version in Ruby doesn't have parentheses. That's because in Ruby, method calls parentheses are optional. So in what happens in Ruby is that the DSLs that you build actually read more like English. They flow slightly better. Some of these differences are mainly stylistic, but in my opinion, the syntax for Swift is a bit worse off than what we have for Ruby. But we have to see as more frameworks, more libraries are being released and look at all the different DSLs that are being created, whether Swift is good for this or not. Right, okay, so this is the code to generate this page, side by side. You can see there are functions like head, title, body, p, form, and so forth. Because HTML uses opening and closing tags, it lends itself very well to a block-based approach. As you can see, you have components such as p, form, etc. being embedded as a block within body. So you can compose HTML entirely in terms of code without using string interpolation. Right? Because we are using Swift, we are also relying on the type system, so there's less room for errors. But if you look at, so the body function, most of these functions, they actually come in pairs. There is one which accepts string, and there is one which accepts blocks, right? So if I go back, so this title accepts just a string. This version accepts a block. Each of them delegate to a tag function, which again it comes in pairs. So this version of the tag function accepts a block. You can see that basically it just runs the block and then wrap it with an opening and closing tags along with attributes and other stuff. Similarly, for the string version, it does the same thing. But if you look at these two function implementations again, you might notice that they are actually really, really similar. If you look at the tag implementation, I'll just page back and forth very quickly. You can see that they are almost the same. So in dynamic languages like Ruby or Smalltalk, we'll try to make them to be the same implementation, just having one function to reduce redundancy. But in a strongly typed language, actually not a strongly, in a static typed language like Swift, the only way to do this, or one of the main ways to do this, is to use polymorphism or protocols. But in this case, Swift doesn't support implementing extensions for non-nominal types. So nominal types are things like classes and structs, and block is a non-nominal type. So you can't provide a protocol and then make both string and this block implement the same protocol. So that wouldn't work. So there's some duplication of code for Swift, right? But maybe in a future version of Swift, I just want to drop in a random tip. Yesterday, someone was talking about what is the map function. Yeah. So, yeah, I found this in a tweet. So have a look. So hopefully everyone knows about basic functional programming after this very short tweet. Okay, persistence. Again, we don't want to be really realistic here because we already have SQL databases, NoSQL databases, we have SQL with ORMs, we have flat files, we have plist, we have object databases, etc. Right? We have a very great list to choose from on the server side. But I wanted to try something different, even if it doesn't work out. Right? Many years ago, there is this framework written in Java called Prevailer. I have no idea if it's still being maintained, but the idea with Prevailer is very simple. All the objects are stored in memory. You don't purge them, you don't reclaim memory. The transactions, the changes that you made to those objects, they are all written to disk for playback later. So that's the basic gist of it. So there are limitations in terms of how you can query the data, because you have to use Java, the native language, to query objects. You can't use things like SQL, you can't run third-party analytics on it. But performance is really, really good if you have enough RAM. So anyway, I have a few premises. One, we only work with structs, right? Because value types in Swift are the future, so we don't work with classes. Let's focus on that. We use protocols, not inheritance. We want to write minimum code, as little code as possible, so we introduce as few bugs as possible. We want to limit it to just arrays and dictionaries, structs, primitive types. So here's a very simple struct. Right? We have an address, we have a few properties. I want to be able to create an array of structs, values, and then write them. So I want to rely on NS Dictionary's ability to write itself as a plist. Because I want to cheat, I want to implement that. Right? So one way is I can write a function called toDictionary, which returns a dictionary of key value pairs. But we don't want to do this for each and every struct that we have, right? Because we want to write minimum code. And we can't rely on NS coding because we have structs. We can't inherit from NS object. So what we can do is we define a protocol called persistent object. It has a function called toDictionary. We introduce a default implementation. The meat of the implementation is in the function gen, which is here. So we use reflection to write the gen function. There's a recursion here, right? Basically, we use reflection to extract all the fields and values and return them as a dictionary. We extend array and dictionary. So basically, we are calling the toDictionary function on each element. So back to our struct definition. Same code. So all we need is to just make our structs implement persistent object, and we will be able to use this code to persist our objects. So talking about persistence, reflection, normally if we have lots of values, lots of structs, and we have a collection of structs, we might need to print them out. Sometimes we will use the print function. But in this case, you see that it prints just one long line, which is not very readable. So instead, we should be using the dump function. Dump uses reflection. It formats your data very nicely. Unfortunately, it doesn't work very well with classes, objects. So that's persistence. Remember earlier we have this function called gen. Just want to point out something that I'm a bit obsessed with in Swift. There's this clause for case let. This one. It makes use of pattern matching to only process labels that are non-optional. Yeah, so for example, if you have a list of integers that can be optional and you look through them and you want to process only the non-optional values, right? One way is you can use for case let to automatically unwrap them. So you only see 1, 2, 3, 5 instead of 1, 2, 3, nail 5. It's very handy. So you don't have to deal with lots of question marks and exclamation marks. Right. Some of you will be familiar with flat map. Right? Very often we can use it to unpack or flatten arrays of arrays. This is one primary use. But there's a secondary purpose for flat map. In this case, it has the same effect as for case let. So this expression, nums.flatMap, basically creates another array, a copy of the array with only the non-nil values. Flatmap is really, really handy. Blamework mainly generates HTML on the server side because we really want to work with Swift. So until we can generate JavaScript from Swift, there isn't a lot of JavaScript support in Blamework. Right? But just adding a little bit of support for JavaScript goes a long way. So I talked about routing earlier. This is how we can map a JavaScript file to a physical file on disk. And then we can use it this way. So through the same DSL, there's a script function. We can include that particular script. Any of you do web development? Right, okay. So I'm sure some of you will have heard of this library called TurboLinks. If you have not, check it out. It's a library created by 37 Signals. I think they call themselves Basecamp now. Right. What it does is it almost magically rewrites HTTP requests so that when a user performs an action, clicks on a link, the page updates without seeming like it has reloaded. So it improves both the perceived performance as well as the actual performance of your HTML application without you having to do anything. You just need to include your script. A bit more stuff. We looked at this extension earlier where we added the ability to write an entire array of structs. If you look at the first line, the first line, there's actually a subtle difference between these two variations. The former version expects exactly this, whereas the second version expects something like this. So for our case, because we want to work with addresses, we need to use this and not this. It's a very subtle difference. I spoke about using reflection to actually read values from structs and then write them to plists. But actually, the reflection API as of Swift 3 is read-only. So you can't actually read from this and then write them back to structs. So it only goes one way, right? So hopefully with addition of more dynamic features in Swift 4, we can do that and make the library more complete. But this is still a useful technique because if you use other persistent mechanism, you can use this method to back up or log events or analytics. So this is something I'm very interested in Swift and generally in languages, pattern matching. Swift pattern matching is very, very powerful, right? But there are some gaps. There are many talks about what it can do. So that's just one thing that I want to point out that it doesn't do at the moment. This is the Fibonacci sequence. I guess most of you will be familiar with this, even though you may not know what it's called. Basically, it's a sequence of, it's an infinite series of numbers. The first two numbers are 0 and 1. Subsequent numbers are the summation of the previous two numbers. So you have 0 and 1, then 0, 1 becomes 1, 1, 1, 2, and so forth, right? So imagine you are in an interview and you are asked a question, right? You are asked to write this fib function so that it can print this out. So after a few minutes, I'm sure that most of you will come up with a variation of this, or maybe use a case statement instead of if else. You can use a loop one, but this is a natural fit for recursion. The cases, the three cases which I talk about, 0, 1, and the general case, they are handled by the if else clauses. I've been doing some work with the language Elixir recently. It has very, very powerful pattern matching functionality. You can pattern match at the function argument level. So what happens is, this is Elixir code. You can see there's 3 functions. They are all single arguments, but you can overload based on actual values. So in this case, you have a function that handles only input 0, input 1, and the general case. So what happens is, now you are able to do pattern matching at a higher level of abstraction. There's less room for errors. And because Fibonacci's series, usually you want it to handle only positive numbers, right? So Elixir has this functionality where you can add a when clause. It's like a where clause. So you can write when n is greater than 0. So this further codifies your logic at the function level, so there's less room for errors. So hopefully, we'll be able to do this in Swift one day. Elixir also has this additional functionality related to pattern matching. You can use it to unpack bits and bytes. I can't show you an example. But basically, if you need to parse binary formats, such as ping files, it can be done very easily in a similar manner in Elixir. So if you have some time, do check it out. It will expand your idea of what can be done with pattern matching. So anyway, to conclude, Swift is a very young language. It is a strongly typed language, but there are still lots of features that can be improved on, especially dynamic features and pattern matching. Personally, I find that it is getting a bit complicated, becoming too much like C++. But I'm looking forward to Swift 4. So these are the things that I have referred to. I encourage you to check them out. Yeah. Thanks for listening.
Any questions? Okay, sure.
Oh.
Sorry, I did have to ask a question. But before that, one comment. Don't use turbo links, it's horrible. Don't use turbo links. Don't use it. Yeah. It's horrible. It completely messes up any JavaScript and stuff like that. It's bad. Anyway, okay, now I have to think of a question, don't I? Yeah. Yep. A question. So, apart from the sort of dynamic stuff that you've mentioned in your talk, what language feature in Swift do you think would be beneficial to writing web frameworks?
Oh, sorry. So your question was what of Swift is suitable for writing?
Yeah, or would you like that thing?
Oh, okay. Well, for one, maybe make the parentheses optional. I think that will improve things a lot. I don't know. I have no idea. Well, the thing is, I'm still not sure static type language is efficient for writing web applications. So yeah, that's that. I'm not sure if Swift as a static type language is good for writing web applications, because if you look at the non-enterprise side of things, so we don't look at things like Java, how many language, how out of all the popular web development language which is not enterprisey, how many static type language are there that is being used for web application development at the moment, front end?
Does TypeScript count?
Yeah, I guess, yeah. But that's more front, okay, I use the word front end, but that's more browser based, right? Yeah. Yeah, it does, yeah. You have a point there, okay. Next. Let's forget about that. Next.
Any more questions?
Nope. Oh, okay. Thank you.